Hello students, let us take one more. Discuss the maxima and minima for the expression. Now ये expression का maxima minima नाम ले लेते इसको से y is equal to. To get its maxima minima इसका derivative लेना is difficult. Let us observe it well. See in numerator we have a chance to take 3s common except the last number 2. So we can write y is equal to 3 common. It will become 2x cube minus 15x square plus 36x. So for these three terms look like the denominator. To make it exactly look like denominator, let's write plus 1. 3 ones are 3, but we needed a 2 in the numerator. So we will write a minus 1 here, the whole divided by the same 2x cube minus 15x square plus 36x plus 1 minus 1 upon 2x cube minus 15x square plus 36x plus 1. This can get cancelled out. So we are left with only a 3 in the first position, and now we are only concerned for this part. Now to know its maxima minima is again difficult because it is in reciprocal form. So when you want to take second derivative, it will be more difficult. Therefore, let us consider say z is equal to 2x cube. We are only focusing on the denominator right now, so that second derivative लेते वक्त problem ना आए. Minus 15x square plus 36x plus 1. So we have taken this denominator quantity as say z. When we take derivative, dz upon dx is equal to, we get 6x square minus 30x plus 36 equal to 0. We can take 6 common, we can divide by 6, and it becomes x square minus 5x plus 6 is equal to 0. We can factorize this. We get x minus 2, x minus 3 equal to 0. So x is 2 or x is 3. Let us take second derivative here. Let us take second derivative. Say we write it here only. Second derivative. The second derivative of 6x square, we are taking derivative from here. So d square z by dx square will be equal to 12x minus 30. Let us put x as 2. So at x is equal to 2, we get the derivative value as 12 into 2 is 24, minus 30 is minus 6, which is less than 0. So we will get a maxima. So we get a maxima in the denominator, which means that this fraction will be minima. And if the minima is getting subtracted from 3, then the overall answer will be taken as maximum. So we get maxima at 2, and similarly at x is equal to 3, 12 3s are 36, minus 30 is equal to 6. This is 6, which is greater than 0, which means we get a minima If in denominator you get a minima, it means that this entire fraction will be maxima. And if maxima gets subtracted from 3, you again get a minima. Hence, at 3 we get a minima. So at 2 we get a maxima. So x is equal to 2 gives you maxima, and x is equal to 3 gives us minima. To get the maximum and minimum value, we can substitute x is equal to 2 in this question, and we will get this as 86 upon 29. And if you substitute 3 in this expression, the given question, we get y is equal to 83 upon 28. You can verify this earlier value of 86 upon 29 is slightly larger than 83 upon 28. Next question. Discuss the maxima and minima of the expression sin raised to 4x plus cos raised to 4x. X is in first quadrant 0 to pi by 2, not including 0 and pi by 2. तो हम अब धीरे धीरे ट्रिग्नोमेट्रिक फंक्शंस की तरफ बढ़ रहे हैं. Very popular question. Let us name this as y equal to. Let us start derivative. dy upon dx is equal to 4 sine cube x into cos x, derivative of sin x, minus 4 cos cube x into derivative of cos x is minus sin x. That is why हमने middle में minus sign लिख दिया है यहाँ पे. And we equate the derivative to 0. We can take 4 sin x cos x as common. So inside we get sin square x minus cos square x equal to 0. Clearly, this can be written as 2 into 2 sin x cos x. You know why? So that this will become sin 2x for us later, into trigonometric formula of cos square x minus sin square x is cos 2x. Hence we have written minus cos 2x as it's in the reverse order. This gives you minus 2 into sin 2x into cos 2x is equal to 0. 2 sin x cos x is sin 2x. Can be written as 4 can be written as sin 4x is equal to 0. And therefore, with a minus here, equal to 0. We can remove minus by dividing by minus 1. Sin 4x is equal to 0. Therefore, 4x can be 0. Then sin 0 will be 0 that way. Or it can be pi. As we know, sin pi is also 0. Or it can be 2 pi. Or 3 pi. Or 4 pi. And so on. It can be any integer pi. Let's divide by 4. So x can be 0 or pi by 4. And when you divide 2 pi by 4, it will become pi by 2, and so on. But our interval for x is from 0 to pi by 2. So, and not including 0 and pi by 2. So the only value acceptable to us should be pi by 4. Let us now take second order derivative. Second order derivative. D square y by dx square is equal to, take care of this minus sign, don't forget this sign. Minus sin 4x derivative is minus 4 cos 4x. Let us substitute pi by 4 here. So at x is equal to pi by 4, you know, therefore 4x will become pi. 4x cross multiply is pi, so this 4x is pi, is minus 4 cos pi. but cos pi is minus 1. So minus 4 into minus 1 is 4. So second derivative is greater than 0, implies minima at x is equal to pi by 4. Let us find the minimum value by substituting pi by 4 in the question of places of x. Sin pi by 4 is 1 by root 2. So 1 by root 2 raised to 4 plus 1 by root 2 raised to 4, as cos pi by 4 is 1 by root 2 raised to 4. This will be 1 by 4 plus 1 by 4, which is 2 by 4, which is equal to 1 upon 2 is your minimum value. एक और question, one more. Let us take again of trigonometric. Maxima minima. F of x is equal to sin x minus cos x. This time x is between 0 to 2 pi. We can call this as y also, or f of x. Let's take first derivative. F dash x is equal to cos x, sin x derivative, and minus cos x derivative is plus sin x. Let's equate it to 0. We can therefore write sin x equal to minus cos x. We can divide by cos. So sin x upon cos x is tan x is equal to minus 1. This happens in second and fourth quadrant, which means x value in second quadrant is 3 pi by 4. Tan 3 pi by 4 is minus 1, while here it is 7 pi by 4. Fourth quadrant angle, 7 pi by 4. You know a multiple of 45 in the fourth quadrant and the second quadrant will give you a negative value, hence these angles. Let's take second derivative. F double dash x is equal to, we have to take cos x derivative, which is minus sin x, plus sin x derivative is cos x. Let us take it at 3 pi by 4. Let's see what happens. So 3 pi by 4 is a second quadrant angle where sine's answer will be positive. So when you put a x here as 3 pi by 4, this value is going to become positive 1 upon root 2 because it's with 45. There are other ways of allied angles to get this answer. We want to do it a little faster. Cos 3 pi by 4 is a second quadrant angle. Cos answer will yield a negative answer. Minus 1 by root 2. Minus 1 by root 2 minus 1 by root 2 on simplifying is minus root 2, which is less than 0. As it is less than 0, it implies maxima at x is equal to 3 pi by 4. Now to get the maximum value, we will have to substitute 3 pi by 4 in the question. So f of 3 pi by 4, or let's write max value, maximum value is equal to, substitute in the question, sin 3 pi by 4 minus cos 3 pi by 4 is equal to 1 by root 2, as we have seen before, and this is minus 1 by root 2 with a minus in between is plus 1 by root 2 is equal to root 2. Similarly, let us now get f double dash 7 pi by 4. And we know earlier we had got a negative root 2 here, so now we may get a positive. Let's verify. Let's substitute here. In place of x, put 7 pi by 4. You will go in fourth quadrant. Fourth quadrant x is there, and sine therefore will yield a negative 1 by root 2 with the existing minus outside will give you 1 by root 2. While x 7 pi by 4 being x 7 pi by 4, cos 7 pi by 4 is a fourth quadrant angle, will yield a positive answer. 1 by root 2 is equal to root 2. This is greater than 0. This is greater than 0. Hence we get a Hence we get a minima at x is equal to 7 pi by 4. Let us substitute 7 pi by 4 in the question and get the minimum value. Minimum value is equal to sine 7 pi by 4 minus cos 7 pi by 4. 7 pi by 4 is a fourth quadrant angle. Sine's answer therefore will be minus 1 by root 2. While this answer will be positive with the existing minus in between, hence minus will stay. Minus 1 by root 2 and minus 1 by root 2 on simplifying gives you minus root 2. We conclude our maximum value is root 2. This is maximum value and our minimum value is minus root 2. Let us now do one question of absolute maximum and minimum. We have a polynomial y equal to x cube minus 3x plus 2 in the interval x is between 0 to 2. So on x-axis the interval length is only 0 to 2. At that time the graph may be turning or not, but at 0 and 2 we have to find the value of this polynomial, and if it is turning at that time, that is maximum or minimum, whatever it is happening, we have to find the value of the polynomial at that instant also. Let us first differentiate. Dy upon dx is equal to 3x square minus 3 and equate it to 0. On solving, we get 3x square is equal to 3. We can divide by 3. X square is equal to 1. Clearly, x is equal to therefore plus or minus 1. Minus 1 is not acceptable as it does not fit in the interval of 0 to 2. So we take only x is equal to 1. So the values at which we want to find the value of this polynomial is 0, 1 and 2. So when x is equal to 0, y will become equal to, put 0 in this places of x. So 0 minus 3 into 0 plus 2 is equal to 2. When x is equal to 1, because 1 was one of the turning point, y is equal to 1 minus 3 plus 2, which is 0. So we do not know at 1 whether it's a maxima or minima. What we want to know is that in this interval, what is the maximum and minimum value? When x is equal to 2, y is equal to 2 cube is 8. So we can write 2 cube minus 3 into 2 plus 2. 8 minus 6 plus 2 is 4. Clearly our conclusion, absolute. Absolute means of these three values, who is the maximum? Maximum is 4. And when is it happening? When x is 2. And what is the minimum? Minimum is 0. And when is it happening? When x is 1. Is the answer to this question.